Howdy. So I'm going to give a PSA while we wait for a few more people to shuffle in. This is going to involve a fair amount of command line ridiculousness. If you want to see that command line ridiculousness, you need to be able to read the stuff that I've written on these terminal windows. If you can't, you should move forward. Although I will say, it's the last session on the last day of the conference. You know, if your plan was to just zone out for this thing, like that's cool too. Like you can stay in the back. So, but you know, yes, sir. No, that one actually says if you just want to zone out, that's cool. So you don't really need to be able to read that one. Although if you can read that one, like one, that's good eyes. But then, so I'll get into the different layout. You don't really need to see that one. You probably want to see the other four. Well, that's my secret window where all the magic sauce is. So, let's see, not there. Say hi to everybody on IRC. Hi. Somewhere I have an actual set of slides. So this is the Postgres logical replication talk. Hopefully that's what you're looking for. So everybody, we think we're in the right spot. Okay, I'm gonna hit play on this for a few minutes. Again, it's good to sit close to the front if you want to actually see this. So I'll give you the quick 30 seconds on this. I actually had this crazy idea. So Postgres 10 has been around for a while in the sense of like, I don't know, back in the early spring, right? They cut the branch and all that stuff. Commit fests were all finished and all that good stuff. And so there have been people doing talks about Postgres 10 and various features and all that. And so I've seen a few talks on logical replication. And they're somewhat interesting, you know, because you're learning about a new thing. But a lot of them had like a whole bunch of like, here's the commands and here's how they work. In the sense of like, you know, this is what the command looks like and here's the syntax of the thing. And that's great. That's a good way to talk about stuff. But I kind of like watched those and thought, you know what I'd rather see is not so much the syntax of the commands, but like, let me see what the commands actually do and how they work. And I thought, well, I don't know who's going to give that talk, but I will give that talk then. So, you know, we'll just do it live and see what happens. I did throw slides together because I felt it was obligatory to at least have a few slides. So we'll do some slides, we'll hit those terminal windows, and then we'll play with that for a while and we'll see how much we can break logical replication. And believe me, we can. And then we can go back to like some slidey, like frequently asked questions, that kind of stuff. So, all right. So who am I? Robert Treat, your host for the next, whatever, hour or less. Let's say 50 minutes, maybe less than that. I've done various stuff that involves computers over the years. I now work at OmniTI. We do, what does this say? This says we do consulting company, helping organizations solve critical business problems through the use of Postgres where appropriate. We sort of have this belief that not everything Postgres does is the right way for your business or your organization. But when it is, it's a match made in heaven. So we're all about that. All right. Some ground rules, I guess, if you want to call them that. More like suggestions. I'm on the Twitters. You probably heard of that thing. I'm at RobTreat2. If you like what you hear or you think things are awesome, by all means, please shoot me a note on Twitter. That'll be great. I will also most likely post these slides, although I will guess that they're going to be low value, but I'll put them online and I'll probably tweet about it there. I also have an email address. If you want to email me afterwards, if you think I've said something stupid or horribly wrong, please type a very detailed and explicit email to me and send it to robert@omniti.com, and I will definitely deal with that in the most appropriate manner. And then finally, again, slides will go up, omniti.com/presents. If you feel like you really need to like copy everything that I'm doing or take pictures or whatever, don't freak out. Like I'll get the stuff online. Even like there's some command stuff, maybe I'll throw that on like my GitHub or something if there's enough interest in it. So for some sort of pre-laid out commands that I have. All right. So what is logical replication? This would be the shortest description that you hear. So it's a new feature in Postgres 10. Hopefully everybody is familiar with the idea of Postgres 10 and on some level familiar with the idea of logical replication. It's a built-in solution in Postgres 10. It's not to be confused with pglogical. If you've heard about pglogical, it's a plugin for older versions of Postgres, I think going back to 9.4, so 9.4, 9.5, 9.6, that allows you to do logical replication. The sort of quick difference, I guess, on like, well, what have we been doing before? So with logical replication, the basic idea is you take the wall stream, you sort of re-encode that into something and then send it over, versus now you sort of get like what we call binary data, which is the wall files that get streamed over to other systems, right? So this is going on that idea of we're going to decode it and ship it someplace, which is what pglogical does. But pglogical is plugin based. This is going to be built into Postgres 10. And the feature sets are different, so you have to deal with that. It's otherwise built on a lot of the same facilities as normal replication, or what we call normal replication today. Again, we transform those changes. We ship them over the wire, just like if you've ever set up replication now, you have secondary machines that are listening to a primary, and it sends that data over, and then they take that and they apply it directly to data the way it's currently done. Now it's sort of recoded back into something that can be applied to local data, right? And you can actually do this in different ways and whatnot, but the basic idea is just think about it as, right, we're going to do some SQL on a primary. Magic is going to happen. It's going to get to the secondary. It's going to almost be turned into like a SQL-like thing that will then get applied to the database. So that's enough of a deep dive into how it's supposed to work. Why would you actually want to use this? Why is this better than what we're doing now? Why are they spending so much time on this? Well, there are some reasons. And so just to sort of touch on those, and if you sort of hit these ideas, like these are the things to be thinking about, right? Partial replication is certainly a big one. Right now, if you do streaming replication in Postgres, it's the entire database or it's nothing, or it's all the databases in the cluster or it's nothing. For most people, that's fine because most people only run one database in their Postgres cluster. You need a primary and a secondary, and as long as you have that, like everybody's happy. But there are cases where you only want to replicate one database when you have several in your cluster, or you want to replicate like some set of tables and not the entire thing. And in those cases, like logical replication, that's like the path forward for that type of stuff. Upgrades are another big one. This isn't sort of an immediate benefit, mostly because this comes in PG10, and there's no real way to get from older versions onto 10 using the built-in stuff. It's not going to be backpatched or anything. I should probably add that in my FAQ. But going from like 10 to 11, I think there's sort of an implicit assumption this will help you with that somewhere down the line. So that's a case that you might care about. You can also think of upgrades, though, in the way of hardware. If you have like a new machine that you want to get set up on, for some reason you don't want to do it binary, which would be odd, you could use this as a means to do that. Schema changes, that's another sort of reason. Because of the way logical works, it's not as tied into the storage format as regular replication. So if you need to make changes to your schema, you may or may not, as we will see, be able to stream data over and then apply it into different schema on the secondary machines, right? So a really good case for that would be if you accidentally did the whole like integer primary key, and now you have 2 billion records in your table, and you realize you need to make that change, and hopefully you have enough time to get this all done. In theory, you could create a secondary machine, make that a big int column over there, and then start streaming the data over and actually get that changed without having to do a big downtime or table rewrite or any of that kind of stuff. So, and just like any other case where the current streaming replication doesn't work, logical replication is another option. We've used sort of trigger-based methods, and a lot of people have, whether it's like Sloaney or like we have a thing called Mimeo that we built for various sort of one-off use cases in different scenarios where it was just nice to have something, right? Well, this will be theoretically a better something because it's built in, it's more performant. And so any of those sort of weird cases, you now have another tool in your tool belt in order to use, which is logical replication. What is logical replication not? Right? This is a sort of an important thing. First off, it is not bidirectional. I'm not sure why people think that it is. There are tricks that you can play, and we may touch on that, but This is not like, you're sending data back and forth and things are getting synchronized or anything like that. It is certainly not multi-master. Again, there are weird tricks that you can play, but by and large, like if you thought this was a multi-master replication system, then I guess you'll be disappointed, but you should be. So that's a hard problem. It is not those things. If that's what you're hoping for, you're going to have to wait for some other miracle to fall out of the sky. So again, it's also not backwards compatible with pglogical. That seems to be a common misunderstanding that's out there. A lot of this work is based off of the work that went into pglogical, so you do see a lot of similarities. And this probably would not exist without pglogical, but there are features that are in pglogical now that are not in the built-in replication that is logical replication. So you have to just be aware of that. If you've got a complicated setup based off of pglogical, the idea that like come Postgres 10, I can throw all that away and just use the built-in stuff probably is not true, right? There are probably things that you're doing in pglogical that you cannot do in Postgres 10. So you can ask a question. I may not answer it, but we'll see.
What is the relationship between development of the two? Like, is pglogical ongoing? Is it going to stop being developed? Was it the basis for the new one, the intent?
So I can't entirely speak to that as not one of the people who's developed it. But my understanding is, I will say, so it was much the basis of what is in 10. And the stated goals at the moment are to continue to develop it going forward and to continue to sort of backpatch things, right, and make that still a thing. So if you're using pglogical now and you're going to go to Postgres 10, because you probably are, you can use pglogical in Postgres 10, right, and not use these features. So that's still an option if that's what you want to do. That's not a problem. So my presumption is they will continue to develop it as long as people are willing to pay them to continue to develop it. So, and I would support that. So why you may not want to do this at all. So not only are there a whole bunch of things that it's not, there are also some bad things in here. One is definitely that there are more moving parts to setting this up if you compare it to streaming replication that we have now. And that's sort of a weird thing because depending on how simple you think streaming replication is, that's an either horrifying statement or it's not a big deal. But at this point, like we've had streaming replication for a number of years. Most people are fairly familiar with it. The tooling there is pretty good. Like there's even like automated scripts and whatnot you can do to set that up. So that's a good thing. And this sort of resets the clock on that, right? Like this is the first version that's going out to the wide community. So expect tooling to need some time to catch up with that. There are also issues around long-running transactions. So data in this particular case does not stream as it's being written on the primary. It actually streams over once the transaction is complete. So if you have like very long transactions that modify a lot of data, that will actually stop things from going over until those transactions end, and then you have a whole bunch of data that has to get sent over and get applied. And so that can be a problem depending on your particular resource usage. If you have certain data that you need to get over there and it doesn't get over there quickly, that could be a problem. The main reason for that is if you look at streaming replication and how that works, it just ships everything over. It doesn't actually have to care about what is real data or what is not real data, right? Because it follows the WAL format, once it gets onto a secondary machine, it still has all the transaction information in there, and so it can determine on the secondary whether you should see those rows or not, right? If you imagine like an aborted commit or something like that. Logical doesn't have any of that information, so it needs to know this is actually data that was committed before it ships it over. So, yep. You can mix and match. So, pgdump is another sort of reason, I guess. It's a little bit non-intuitive how people should reason about what pgdump should do when you have like sort of large, complicated PG logical setups. As an example, in setting up a logical replication system, one of the things that you put into the system is credentials for how to connect to, like the primary from the secondary. When you pgdump on that secondary, there's a debate on should it actually show the connection information there, or do we not show that, right? And I think you could probably make arguments either way. And so that's sort of a thing that you kind of need to be aware of. That might be a real problem for you, or it might not. And you may be able to get around dealing with that problem. So just sort of another flag. If for some reason you're doing a lot of stuff with pgdump, like that could be a problem. Another one is replica identity, which I'm not going to talk a lot about because it's like confusing and kind of annoying. But the fact that there's a piece of this that's confusing and annoying is a reason not to use it. And if you screw things up badly enough, or you are trying to do complicated enough stuff, you will end up having to figure out what this really is. So, which is sort of my subtle way of saying I tried to ignore even talking about this, except that I screwed things up badly enough as I was like playing with this stuff that I had to figure out what it was in order to fix what I was doing. So hopefully you don't fall into that, but it's like, this has actually been in Postgres since 9.4. My guess is that most people have never used this or even looked it up and just breezed right past it in the documentation. That's what I've certainly done up until now. So now I know it. Now I feel like that's time spent out of my life that I don't get back. The other sort of really big thing, pglogical doesn't really give you a failback mechanism. So right now, again, there's a lot of tooling around streaming replication. You can do failovers and do failbacks, and like there's PG rewind and sort of tools like that in order to do more complex, sort of failover scenarios and HA stuff. pglogical doesn't have that. The built-in logical replication doesn't have that. It's actually more advanced capabilities in the pglogical plugin set. So again, that's one where if you're using pglogical, you think you're going to use the built-in stuff, that could be a problem. And personally, like I think for most people, if you're just sort of looking for that simple, 2-node or maybe 3-node HA cluster, that makes logical replication sort of a potentially poor way of doing that, right? The fact that you can't just fail back to the old one, or there's no way for, like a new, if you're doing like a 3-node cluster, for the 3rd node to actually repoint and know that you have the right info there, there's not really a good way to do that that's provable. And so in that case, like you may have missed some data or something like that. So, so the failback situation and failovers are kind of a problem. I think a lot of that will actually get worked out for 11 once that gets released, but at the moment, like that's definitely a thing you need to be aware of. Again, if you're gung-ho about setting this up, definitely check out how are you doing failover now and how do you manage, how are you going to plan to manage that. So, so that's all my slides-ish. And so I'm going to jump into doing some stuff on the command line. And I will say, like, again, sort of my motto is, and I don't know if you all know who Gene Kranz is. He was the Apollo mission director. The F is Gene fucking Kranz. So he's a pretty awesome dude. I had the opportunity to meet him. I always generally think when it comes to the new Postgres stuff, I really don't care what it was designed to do. I know many of the folks who are hackers in the Postgres community. They all think they know how the code works. And what I found over the years is, like, much like every other programmer, it doesn't always work the way that you thought it was going to. And so, again, let's just go into the command line and see what we can do. All right, not that command line. All right, so here's what I got going on. I'll explain this a little bit. I didn't even think I have a mouse pointer. So this window up here, if you're looking on that side, that's going to be a server running, so logs are going to be over here. You're going to see stuff with that. This is going to be some command line where I'm going to do interaction on the primary. Down here is going to be where I do interaction on the secondary, and these are the logs of the secondary. And this is all the secret sauce that I don't want you to see, so I've used that tiny font. So, AKA, this is where I'm going to copy and paste stuff, because, like, typing is hard. So, and so as you can see, so this is just a pretty simple setup. I have a couple of things in here. So Pagila is a sample database. It probably needs updating. It's based off of like a DVD store schema, and nobody actually uses DVDs anymore. So like anyone under like 25 doesn't know what I'm talking about. I plan to convert it to like an online streaming like television schema service, because that I think people know what it is. But I'm going to use that schema and do some replication, and that's what we're going to play with. Primarily so I have the option to go back and recreate it if I need to, which we probably will need before we're done here. The PGSQL directory, shout out to all you FreeBSD users. That is where the actual binaries and stuff are. So if you want to see that, I cannot type, nope. Right, so I have a bin directory, which is where like Postgres and pgdump and all that stuff is. This is Postgres 10, as you can imagine. There's include and share. What else we got here? what is the Postgres? Oh, Postgres directory is the source tree. So the way that I did this is I just did a git checkout, and then I just did like configure with a few different flags, and then make install. I think you can see the version is 10 beta 4. The first time I did this, I ended up on Postgres 11, and I went through and did a bunch of stuff, and then realized I didn't use the right branch. So then I went back and redid it again, this time specifying I wanted the Postgres 10 branch. Didn't seem like it broke anything, so fingers crossed it won't break anything other than what I mean to break. We'll see. So that's Postgres version 10. What else did we have here? And steps is my secret file of steps that we will use. Whoop. I'm using Vim just because it gets people excited. I mean, like one way or the other, right? Like it's either like, oh my God, that guy's using Vim, or like, awesome, that guy's using Vim. I have set up a path statement in each of these windows. So if you try to duplicate this later and you say like, he didn't seem to type out as much stuff as I have to type out, I set my path to be in this like pg10 directory on my machine, just so it'd be easy. All right, so we're gonna make some data, all right? Copy and pasting, also hard. It's just not as hard as typing. initdb -d data1, hopefully this is not a shocker to anybody. Also, hopefully it works. Oh, look at that, we have a database in data1. That's pretty fancy. And now I'm gonna start the database. Wow. Maybe I need to make that window bigger. I can't use it either. So starting with Postgres binary in data1, I'm gonna put this on port 54321, so we know that it's the first one I created. And then passing in this flag, wall level equals logical. That's probably the one sort of really important configuration that you need that's different from the base settings. You need to tell it to actually put information for logical replication into the wall file. So I'll hit enter on that, and we'll all say, wow, we can't read what that did. I'll expand this just a bit. All right, so we've started a thing. It's listening all over the place. It's on the Unix socket. Everything looks great. It shut itself down-ish, and then it started itself back up, and so now it's ready to accept connections. In theory, we have a running Postgres 10. I know you're all very excited. All right, so now, really, look at that. I'll go over here and do my PSQL. So creating my database, because you need to do that to replicate a database. Hey, I've got tricks in my PSQL RC. You may have seen those. You can only imagine what that is. So the database is there, and then this is the schema file. Right, and you're gonna see a whole bunch of stuff go by. Like, look at that, we're creating stuff. Schema file's old, see, because DVDs are old. So PGSQL exists in Postgres 10, in case you were concerned about that. So that's there, and now we're gonna do some data. And boom, we have data, right? So pretty straightforward. You've probably all hopefully done a PG dump and restore at some point. That's what that basically looks like. Let me do this. We'll hop into the database. I've done a little bit of modification so you can see which database we're on. I'm the Postgres user because it makes demos really easy. You probably need to be the Postgres user in order to really have a good time with this. I'm on the 54321 database, so you should all remember that. I'm gonna move over to Pagila and do some \d stuff. Like, look, we have all these tables, right? And again, DVDs, so we have like actors and films and which film they've been in, and then there's customers and payment stuff and all that stuff. Pay no attention to those partition tables for those of you that are gonna cause me trouble later on. And then we have some sequences and all that junk. So it's pretty straightforward, and there is data in these tables. All right, look at that, we have data. So it's a database, woo! All right, so I'm gonna actually go ahead and now do all the really magic stuff. So we're gonna create a publication. This is the syntax it uses, and it's more complicated than the docs, but this is basically it. We're creating a publication. I'm gonna call it pgpub. You can call it whatever you want. If you look at online demos, I feel like most people call it mypub, but I'm like really old school, so like I'm not going to use a my like prefix on anything. I'm going to use a PG prefix on my stuff. So keeping it real. So I'm going to create a publication, pgpub. This is my publisher. And again, that's another thing. It's a whole new set of syntax because every time you create a replication solution, you need an entire new set of syntax for what to call things. So, so in this case, we call them publishers, which is the primary, and we have subscribers, which are generally your secondary machines, right? And so we're creating a publication here for table actor. It's there, great. And if you want to see that, there's actually ways to see this. All right, pgpub, pub owners, Postgres, and I'm doing inserts, updates, and deletes. Again, there's syntax options for when you create these publications. You can't actually just do partial replication in the sense of I only want to do inserts to get replicated logically, or I only want updates, or I only want deletes, or whatever, right? Or some combination thereof. So there is flexibility there as you start to play around with this stuff. So okay, so we have our publication there. Oh yeah, this is, in case you don't want to type that out. So there's a thing about PSQL. It's been around for a long time. It's really awesome. If you want to use the PSQL command to see your publications, it is \D capital RP. Yeah, we've used all the letters basically at this point that you can use for all the other features that Postgres has. And so like this was sort of the only combination that was left. If you have a hard time remembering this, because it doesn't really feel like the best mnemonic out there, just be like, we used up so many letters, we were just like, derp. That's how I remember it. That's very easy. So there's your publishers. Look at that. We have logical replication going-ish. But it doesn't really seem fancy, right? Like, because I haven't created a second database. So I'm going to go do that, because I bet you'll all be more impressed when you see that it can actually go to a different database. Sort of. All right. Oh no. Yeah, not really. Don't rely on that. Yeah, they're in the wall. I mean, if you make changes, they'll be in the wall. So you'll sort of see how that works out. And it's different if you have multiple subscribers. All right, so done the same basic thing. I did this one on 54322, because it's the second one I made. And then the wall level is logical, because again, you need logical, because like that's what it's all about. And then I'm going to do some PSQL over here. Oh, good Lord. There we go. Oh, hey, guess what? I skipped a step almost. So connected to a database, the first thing that you learn when you start setting this up is that none of the schema is actually replicated. So we're at that stage, right? Like I've just created a database on the secondary because I actually have to go create all of that stuff in order to be able to replicate anything over there. So sadly, for some people that's like really sad and they don't like that. I guess from my opinion, I would say that actually allows you to do a lot of interesting things. I'm going to go back up here and grab the little schema thing. I'm going to change the port because like that would have been bad. So now I have the schema over here, and I know that it worked. This is why I left the error message in there, because I have the error there. So everything's good. Very excited. I will jump into the database now. And just to prove there are no shenanigans. So if you look over here, I have an empty actor table. All right, it has no data. This one has data up here. All right. So, look at these fancy commands. So now we're going to create a subscription on the secondary. And before I hit enter, so again, the command, the more complicated versions of the syntax in the docs, but you're basically creating a subscription. Again, I'm calling it PG sub because like that's how I roll. And then you pass in this connection information, right, to tell it where do you go to get the other thing. And this probably shouldn't look too surprising. Here I'm just specifying a port and a database name because that's all I need to do so it knows where to go. Obviously that could be any of the various ways that works. And then you tell it where to connect and then also what's the publication that you want. In my case, I want publication pgpub. All right, so I hit enter and I'm like, oh my God, like logs are doing stuff. Let's see, did it work? So we started logical decoding for slot pgsub. Logical stuff is happening. Down here it says logical replication, table synchronization, worker for scribe pgsub. Table actor has started and then it has finished. Right, so that's these bits here. So by default, when you set this up and you actually go subscribe, it syncs all the data over. And that's just as horrible as it sounds, which is like it just grabs all the data, sucks it over the pipe, and sticks it into the new thing. So, if that's bad for you because you have like 50 million rows or something, take that into account. In this case, it's trivial, so we don't care. But that's now working, that's a thing, and it's finished. So look at this, millions of man hours allows us to do this. Fantastic, we have data now. I know you're all very impressed. It does like the most simple thing it possibly could do. So that's good. If we didn't get that far, we'd be in trouble. I have to do the obligatory, so let's do like that. Let's change, I don't know, let's go Joe. So we're going to do update, actor, set, what is that, first name equal to Jose, because we're like that in this year, where actor ID equals 9. An update has happened, and if I now do this query again, you don't see it because it's an update and it's Postgres. It goes to the end of the table. Hey, look, it's Jose. Right, I've updated data. It went to the other machine. Again, spectacular. We can also delete stuff. This will be slightly more painful because there's like foreign keys and stuff. If this were a real database, we wouldn't use foreign keys. That's what the app developers tell me. Delete from actor where actor ID equals, who do we want to get rid of? Cuba, you're back on the watch list. Nope, that didn't work because of foreign keys. Let's delete from film actor. So film actor is a join table. In case you're wondering, the only thing we have data in over here is the actor table, right? Because that's the only table that we actually set up. So I'm going to delete all this stuff over here now, which means it's going to be gone, right? Because I'm not replicating on this table. Hopefully this will work, or else I picked a bad person. Okay, so we got rid of all of their films, and now I can delete them from the actor table, where actor is 15, and now if I look over here, from actor, where actor ID equals 15, and you get nothing, right? Which is what you would expect, because now it's all gone. Okay, so now we actually have a working replication setup. It does the simplest thing it could do. Everyone's very excited. If you want to see what's going on, right, there are ways to actually look at this, and I'll run a few of these because you might want to see this. There's a thing called pgstat replication. It shows a bunch of different information. When you end up going to try to figure out, like, is it working or is it not working, and building your monitoring solutions, this is what you're going to actually probably be looking at. So we have that going on. And then we have, you may be familiar with PG replication slots. How many of you have actually ever looked at PG replication slots? Yeah. So again, this builds on the same facilities, right, that regular streaming has. So some of these things are similar. Sort of the main thing probably here is, like, if you look at the slot type here, it says it's logical. So you can tell this is the one that's doing logical replication. Or I should say this is one that is doing, so it could be one of many. The slot name, right, is the name of my publication. It's pretty straightforward. It's active. There's a true flag there, right? So that's cool. And then on the subscriber, you can look at pgstat subscription, and hey, look at that. tells you when was the last time it received data and sort of where it is in the wall stream. And again, you have your subscription name, which here is PG sub. So that's where you're going to sort of build those facilities on top of if you want to sort of keep track of what's going on. All right. So now we can do some other fun stuff. Like, let's add some tables into our thing. So we're going to do alter subscription. Nope. We're going to do alter publication. pgpub. Command completion is awesome. Add table. Let's do film. And let's do, geez, I deleted film actor. That would have been useful. Let's do country. That might be a good one. So now if you look in PG subscription, maybe, yes. Hey, look at that. Oh, I got nothing. I broke it. This is what happens. Nope, PG publisher. I forgot where I was. PG publication, right, that's still there. There's another thing called PG publication tables, and that tells you like what you're actually replicating, right? So again, pretty straightforward. When you do that though, you actually have to let your subscribers know that you've made some changes. Before we do that, and I will do that. Let me think here. I feel like I want to break some other stuff before we actually keep doing things. So there's a lot of stuff we can start doing with, like, and questions that start to pop out when you do this. All right, so like one of the things would be, people always ask, you know, truncate is like sort of on my list of like, what would you like to see if the system works? And let's do, hold on a second here. So we're going to refresh the subscription, right? So we're telling it the publication has changed. And then when you do that, you look over in your logs, and it's like, oh, okay, you've added the film table in, we're going to synchronize that. You've added country in, we're going to synchronize that. Right? You can see that that action just goes on as soon as you do it. Yep. The names have to be the same. The schema can be different. So we'll mess with that in a second. But the names have to be the same so it knows what. Yes? There might be an actual technical reason. I think, yeah, I don't know. Like, I mean, I think from a usability standpoint, this is the behavior that you actually want, because you have the ability to then better control what is going to happen, right? So you can actually make your modifications on the publisher without worrying that it's suddenly going to go to everywhere when you make that change. You can actually, like, if you have multiple subscribers, you could go to each one and then tell it, go ahead and get the new stuff and do that sort of in parallel rather than having it automatically go out to everything. So there may have been some other reasons, but that seems to be the main thing to me that is set that way. Yes? Pardon? A little louder. Yes. The schema can be different to a degree. So we'll do a quick check here. So the country table, hey look, we have countries in our country table, right? So that's all good. So I'm going to truncate the film table, which probably won't work because I'll get some kind of foreign key thing. How many of you think that will actually replicate or think that it will not replicate? If you don't think it will, put your hands up. Yeah, I'm being friendly here. That's not going to work. So let's see. This will actually break because of some kind of thing. Oh, film actor. Okay, so we're just going to cascade that because, like, why not? Right, and I'll prove that I did have data over here. Right, hey, look, there's really data there. Lots of it, too, right, all these films. So if I truncate film, cascade, whoosh, wow, that truncated a lot of stuff. I did not expect that. But it didn't truncate country, so we're still good. We're still in good shape here. Now, I look over here, right? So again, in the logs on the first one, you can see, right, the statement truncate film happened, right? That clearly was a thing. If you look down over here, like, you don't see anything in the logs on the secondary, and you shouldn't. Like, all this data is still here, right? So truncate, it's like the special case of all sort of like trigger-based, logical, like all those solutions. None of them really know how they want to deal with truncate. And part of that is a technical reason. The way that truncate is implemented, it doesn't really do anything for the wall stream. So like it just changes, like it deletes the file at the file system level. So there's not like wall entries to put into the system, right? And so then there's nothing to actually stream, and so there's nothing for the secondaries to figure out what they need to do. So that's weird. Like if you use truncate a lot, this could be a problem. And in fact, there are arguments, like I think most people would just interpret it as like, well, by truncate, we basically mean like get rid of all the data. But there are scenarios that you might do where maybe you're deleting off of one system and you want to delete those records from the other system, but if the other system has data that is like a superset of wherever you're subscribing from, like you may not want to get rid of everything, right? Like you may be in some kind of weird situation where you're trying to like dedupe data from two different systems, and then you could get rid of it all on one, but there are going to be extra rows set up on the other one that you'd want to keep. So, I mean, there are sort of some probably archaic or weird reasons that you wouldn't want it to work that way. So that makes it a little more difficult to implement. Yes?
So if you loaded the same schema to both those databases, your subscriber then, when it synchronized the data, did it turn off foreign keys when it brought in that data? Because clearly you didn't have the table that you couldn't delete from up above on the first source because of foreign key dependency.
Right.
None of those records existed on your.
Yeah, essentially it ignores that. So depending on what you're doing, like this is another one that's like, it's a little complicated. Like with triggers and foreign keys, you kind of have to look at how you've designed those to interact. And at the basic level, it's kind of just going to ignore that. And that's probably what you want. But if you have certain triggers in place that you actually care what they do, getting those to interact with the system and do things that are complicated is complicated. So, but there are ways, like if you ever looked, like there's different session settings that you can have for like how triggers are supposed to be enforced and not enforced, and you can change that on tables, right? And that's what I say, like when I warn sort of like there's a lot more moving parts, like this is the kind of thing that you start to see that I think the basic way that this works is probably what most people want, which is I just want this one table, don't worry about the foreign keys or anything like that, and just do it. But there can be scenarios where you start to see like you have to play with table subscription information or table schema definition information in order to get it to work the way that you might want. So. Triggers can run on the replica. So one of the things that I can do, like if I want to, right, so we've got select all from actor, where ID equals 10. Nope, because it's actor ID. So good old Christian, right? So I can actually, I guess I'll prove it's the same. Actor ID equals 10. So these are the same. I can update this right now on the secondary, right? Update actor set first name equal to, let's go with Chris, where equals 10. Like, oh my God, data is now out of sync, right? So, I mean, just realize, like, if you've made fun of, like, certain other databases because, like, they can't keep their data in sync, like, this is why they use logical replication. So, and all those wonders are coming to you now. You have that capability. Now, so then we'll do some, let's say I didn't really like that. I'm going to do, this is not going to work the way that you think it would. Let's do update actor set first name equal to Christian, where actor ID equals 10. All right, so this is more of a trick question. What do you think is going to happen on the secondary when I do this? So anyone think that the secondary will be updated and will say Christian when I get done? We got at least one says yes. I'm going to be honest, I have no idea. I don't think it's going to. But yeah, yep. Yeah, so yeah, generally it works off the primary key, which is what it's doing here. Okay. Well, I definitely did an update, right? And if you want to see this, it is definitely Christian up here, and you can see that the last update time has changed. So let's see. Oh, it did actually work. Shows what I know. That's interesting, actually. I would have reasoned that it wouldn't have, but only because I've broken it in weird ways. No, the primary keys are there. Yeah. I think. Oh, good call. That might be it. I'm going to try to break this in a different way, though. Just because.
On the trigger question, so if you had the trigger on the replica, will it just run like any other trigger?
You have to arrange it.
I think what he said, but I didn't quite catch your question.
You have to make, there's like, that's what that replica identity is all about.
Oh, okay.
Yeah. Yes.
So by default, the triggers won't run, is that what you're saying?
I would,
Okay, but they either can or can't.
Depending on how you've defined the table. So we'll do it this way then, right? So now if I say update actor set first name equal to first name, where actor ID equals 10, right? So now do you think it will actually change? So we got at least one yes. So this is the pre. I've changed it to Chris. Update 1, and hey, it still works. You can't break it. Everything replicates. It's magic. Do we want to try any other versions of this? Or we're all pretty confident we know how it works now? So truncate doesn't work. Updating things to the same does work. Yep. These are the questions that you start wondering about, right? Like, well, is it always going to work? All right, so we're back to Chris down there. Update actor, we're going to do this. Update 1, and it still works. What if you match the slave? Oh, to set it to the thing over there? That will still work. So, right, you want to update. So if I do, you want to do. So I got Chris over here, right? And then let's just pull that up, and then I'm going to do this one. So this will actually change. This is different than what we have in the table, right? Well, that'll change a lot of stuff. Where? Was that your goal? Or do you want an and clause? First. Well, so we're Christian over here. Well, but it won't, right? Because his name isn't Chris on the first one. So it won't update anything. Right? If I write it like this, nothing will get updated. It doesn't update the primary, right? Because this where clause doesn't match any rows, right? Update 0. So when you don't update anything, it doesn't replicate, obviously, hopefully. So if I do this version, right, because it's case sensitive. So now we've updated, and he's Bob. All right, which is what you would expect, hopefully. I've tried to make you not expect that. All right, so let's play around a little bit more. So I'm going to look at this country table. So this is pretty basic. Hold on. I'm going to do alter subscription, PG sub. So I'm going to do disable for a second here. So this disables the subscription, right? And hey, look at that. Logical application, apply worker for pre-sub will stop because subscription was disabled, right? And I'm doing that because I want to mess around with the schema down here. First, I'm going to alter table country. Drop column country ID. That probably won't work. Drop cascade. Okay, so we dropped a bunch of stuff. Let's go back and look at our country. I'm gonna alter table country, alter column country. You like tables that have a column that's the same name as the table name, and it's not the primary key. It's fantastic. Alter column country, type text, because like why wouldn't you use text, right? Nobody uses varchars anymore. Now they all use varchars or they use text, I guess. And then we're gonna alter table country, add column country ID. And I think it's an int up here, right? It is an int. So let's make that a big int, just because. And then we'll alter the table, country, add primary key on country ID. What? It does? I don't have time for that. How does it have nulls? It's not null up there. I must have deleted something that cascaded somewhere. Delete. Oh, right. Oh, yeah. That makes sense. Let's see. How do we deal with that problem? Let's just pretend like we're not going to worry about that. All right. Well, before I enable this, so now we have a country table. Country. So now we have a country table. I'm going to make this a little bit bigger so you make sure you can see. So this table definitely does not look like the one up here, right? Like we all would agree with that. It looks similar, right? Like, and this might be something that you'd want to do. It's painful to do this. If you had actually a lot of rows in here, this would be painful to do, to change a varchar to a text and then int to big int, right? Like that's a scenario you may have lived through before. So I'm now going to enable my subscription. And then this shouldn't work. The big problem now is like it can't actually replicate because I don't have a primary key on the subscriber. So how am I going to solve that problem? The logical worker started on the second one, just in case. So let's do update country, set country equal to country. So that updated a bunch of stuff. Let's see what we have in our table. Right, stuff is actually happening. If you're really keen and you're reading this, right, I need to do the replica identity or add like a primary key, right, in order to make this work. So if I look at country, right, like my country IDs are all blank. If I really wanted to, I think I could do this. Update country, set country ID equal to 1. And then I could do this. And then I think I can do this. Doesn't want to do that. Up here, this is where you get into, I probably should just go replica identity this, but that's not fun. Nope. Doesn't like that at all. Yeah. So, no, that can't be true. Oh, it could be true. All right, so they're telling me I'm out of time. I can't prove that this works, but it would actually work. What I could do, yeah. I'm going to wait till everybody else shows up. There's got to be people in those other rooms. If the schemas don't match in certain ways, like if you drop a column on the subscriber and that column should actually exist, like replication basically stops. If you delete it on the publisher, it's fine. Replication will continue and that column will be left alone. Yeah, right. If you had a not null constraint on the subscriber, then it would error out because it'd be trying to do that. But if you added a default in, then it would be okay.
But it won't propagate with the subscriber.
It will propagate, yes. It will certainly try.
The column dropping will propagate to the subscriber.
Oh, no, I'm sorry. No, the column dropping won't. The data will once you keep updating the data. So just to prove, I'm going to go grab some data here. I can make it work. What? The people aren't here yet. Yeah, I know, but the people aren't. Okay, so I've sent some new data in. Let's see, hopefully this works. Oh my lord, it still didn't work. Oh wait, I needed to do it here. Truncate country. And then I'm going to truncate over here again. Oh, cascade. And then I'm going to put a row in. And then, yeah, no, there's only one row. It's got to work now. I added the primary key. See, it did work. So, and I will grab the data. Let's just do that. So somehow, I feel like this still isn't quite right. So look, so I only have one row in the table up there, and that row is here. It's in country ID 7, like it showed up. Armenia is there. So, dude, go close the other ones. You got to get all those other people out. Yes, it is. You can do that. All right, so I have some other slides that I'll talk about real quick. Look, there's still people coming in. They're not ready yet. This will be really fast. So as you can see, you can play around with this stuff quite a bit and try to figure out how it's all going to work, because it's really interesting how it breaks and doesn't work, and what you can do and how you can mess with the system. There are some other config parameters you probably want to be aware of, but they're all like basically the normal stuff, right? Wall level, max wall senders, your listen address, and all that stuff. On the subscriber, it works very similar, right? Max replication slots, max worker processes. There's other stuff there. Monitoring, I won't rant about that now because apparently I'm out of time or something. Yeah, whatever. There, again, are views, which I selected on some of those that you can use for observability, which is what you really will need to do. This will show up in pgstat activity if you're looking at that. That's another change in 10 that I think is a good thing. Steven, is it a good thing?
Yes.
All right. Lots of stuff people want to know, how data is transferred, blah, blah, blah. Any of these are important. Yes, table can be more than one publication. It doesn't replicate system catalogs. It doesn't replicate sequences. So you have to figure that out on yourself. Again, failover is a problem. You can have triggers on the subscriber. Be careful with that. It does work with copy. You can cascade subscribers-ish. You can't really, but you can pretend, because you can make a publisher on the secondary instance and then subscribe to it from a third one. So slides will probably be available online. You want the video? I don't know about the video. Buy these people a beer. They did most of the heavy lifting here, especially Peter Zelnick. Notice Stephen Frost's name is not on this slide. I'm just saying. So thank you, everybody. I hope you had a good time. Safe travels.